Hi students, this is Alex here. In this video we are going to discuss about the integration as an inverse process of differentiation. We are going to see how the integration formulas are obtained from the differentiation formulas. We are going to list the differentiation formulas here, and using this we are going to write the integration formulas on the other side. The first formula we are going to see is, suppose if y equal to x power n, then its differentiation dy by dx is n x power n minus 1, where n is an integer. Suppose if I have x power n plus 1, using the same formula we can write its differentiation dy by dx as n plus 1 into x power. We have to subtract 1 from the power. So if I subtract 1 from n plus 1, we get n. So using this, we are going to write the integration formula. That is, integration of x power n dx is nothing but reverse of this. So differentiation of n plus 1 into x power n is x power n plus 1. So integration of x power n will be x power n plus 1, but we don't have this constant n plus 1, so this we take to the other side as a division. So divided by n plus 1, and usually we put a integrating constant plus c. And here this formula is not applicable when n is minus 1. If n is minus 1, then denominator will become 0 and numerator will become x power 0. So x power 0 by 0 we get. So it is not applicable when it is minus 1. For any other value, it is applicable. So this is how we get all the integration formula by the inverse process of the differentiation. Now let's see the second formula. Suppose if y is equal to e power x, then its differentiation dy by dx is also e power x. So when I want the integration of e power x dx, so the inverse or the reverse is again going to be e power x only. So which is e power x plus c. Now coming to the third formula, suppose if we have y equal to a power x, then its differentiation dy by dx is a power x log a. And if we want integration of a power x dx, then we are going to take the reverse of this. So a power x log a integration is a power x. So we are going to write a power x here, but we don't have the constant log a here. So it will be written on the other side as a division. So divided by log a, then plus c. Then fourth formula, suppose if y is log x, its differentiation dy by dx is equal to 1 by x. So now if I want the integration of 1 by x dx, we are going to apply the reverse of this. So this answer is going to be log x plus c. Now coming to the next formula, we are going to take y as sin x. Then its differentiation dy by dx is cos x. So if we integrate cos x dx, the reverse of or the inverse of this differentiation formula gives the integration of cos x dx as sin x plus c. Next formula, if y is cos x, then its differentiation dy by dx is minus sin x. So if I want the integration of sin x dx, then using the inverse of this, we have to say it is cos x, but there is no minus sign here, so this minus sign will be taken to the other side. So the answer is minus cos x plus c. The next formula, suppose if y equal to tan x, then its differentiation dy by dx is secant square x. So the integration of secant square x dx is, from this we take the reverse and that gives tan x plus c. Then next one, if y equal to cosecant x, then its differentiation dy by dx is minus cosecant x cot x. So from this we can take the integration of cosecant x cot x dx as the reverse of this, which is nothing but cosecant x, but there is no minus sign here, so we take this minus sign to the other side. So minus cosecant x plus c. The next one, y equal to secant x, then its differentiation dy by dx gives secant x into tan x. So now integration of secant x tan x dx gives, from this reverse we can take it as secant x plus c. The next one, y equal to cot x, and differentiation of cot x will be minus cot x is minus cosecant square x. From this we can take the integration of cosecant square x dx is minus cot x plus c. We don't have minus sign in this integration, so we carry the minus sign to the other side. So integration of cosecant square is minus cot x plus c. The next formula, if we have y equal to sin inverse x, its differentiation dy by dx is 1 by root 1 minus x square. From this, the integration of 1 by root 1 minus x square dx can be written as sin inverse x plus c. We have taken the reverse of this. Integration of 1 by root 1 minus x square is sin inverse x plus c. Coming to the next, suppose if y is tan inverse x, then dy by dx is 1 by 1 plus x square. So using the reverse of this, we can write the integration of 1 by 1 plus x square dx as, from this we get tan inverse x. So we write here tan inverse x plus c. The next formula, y equal to secant inverse x, then its differentiation dy by dx is 1 by x root x square minus 1. So using the reverse of this, we can find integration of 1 by x root x square minus 1 dx as secant inverse x plus c. Now next one, suppose if we have y equal to 1 by x, and if you want dy by dx, so this 1 by x is nothing but x power minus 1. Now using the first formula n x power n minus 1, we take n x power n minus 1. Here we are taking the n as minus 1, we apply the first formula, and this is nothing but minus x power minus 2. And when I carry this to the denominator, we get minus 1 by x square. So if we want the integration of 1 by x square dx, we can directly write the reverse as 1 by x with a minus sign, because here we have minus, but in the integration formula we don't have minus, so we take this minus sign to the other side. This is nothing but minus 1 by x plus c. In the same way, next we have y equal to root x. So this is nothing but x power half. When you want the differentiation of x power half, using the formula x power n, n x power n minus 1, which is 1 by 2 x power. If I simplify the numerator, we get minus 1 by 2, and this term can be carried to the denominator with x power half. Now this x power half can be written as root x once again. So if we want to find the integration of 1 by root x dx, we can write the reverse of this from here to this, but we don't have 2, so the 2 will be carried to the other side, so we get 2 root x plus c. So in this way we can get the integration formula from the inverse of the differentiation formula. And now let's solve few problems based on all these formula, which is purely based on the method of inverse of the differentiation formulas. Now let's solve the problem 1. Now the question is integral x power 3 by 2 plus 2 e power x minus 1 by x dx. So we are going to apply this formula, integration of x power n is x power n plus 1 by n plus 1 for the first term. So it will become x power 3 by 2 plus 1 divided by 3 by 2 plus 1. Then second term, e power x integration is e power x only, then minus integration of 1 by x is log x. So here it will be log x, and finally there will be a constant c. So the next step, let's simplify further. This will become x power, after taking LCM, it will be 3 by 2 plus 1. So numerator will become 3 plus 2. Totally it is 5 by 2. So x power 5 by 2 by 5 by 2 can be written as into 2 by 5. And the rest of the terms written as it is. Plus 2 e power x minus log x plus c. Now coming to the problem 2. We have root x into 3x square plus 2x plus 3. Let's expand this. Integral, this is x power half. When I multiply inside of this, it will become 3 into x power half into x square. In the same way, 2 into x power half into x, and this is 3 into x power half dx. Now we add the power when bases are same, so this becomes x power half plus 2. So half plus 2, after taking LCM, we get 1 plus 4, which is 5 by 2. So here it is 5 by 2, and here it is half plus 1. By adding the power we get 3 by 2, and last term as it is. Now coming to the integration of this, X power n formula is x power n plus 1 by n plus 1 plus 2 into x power 3 by 2 plus 1 by 3 by 2 plus 1. Then 3 into x power half plus 1 by half plus 1 and finally plus c. Then simplifying this further, we get x power 7 by 2 into 2 by 7 plus 2 into x power 5 by 2 into 2 by 5. So all are product. In the last term, 3 into x power 3 by 2 into 2 by 3 plus c. So totally this is 6 by 7 x power 7 by 2 plus 4 by 5 x power 5 by 2 plus you can cancel these two, 2 x power 3 by 2 plus c. Next problem, we have x cube plus 3x plus 4 whole divided by root x. We have to divide individually. So this is x cube by root x, which is x power half. Then the second term is 3x divided by x power half plus 4 by x power half into dx. Now, when the bases are same and it is division, we will subtract the power. So x power 3 minus half plus 3x power 1 minus half, and this we can carry to the numerator as minus half. Then we have dx. Now simplifying further, after taking LCM, we get x power 5 by 2 plus 3x power 1 by 2 plus 4x power minus half as it is. Now applying formula, we get x power 5 by 2 plus 1 divided by 5 by 2 plus 1 plus 3x power half plus 1 by half plus 1 plus 4x power minus half plus 1 by minus half plus 1, finally constant plus c. Now this will become x power 7 by 2 into 2 by 7 plus x power 3 by 2, already there is a 3, and into 2 by 3 will come. Then plus 4 x power half by half will come as a product 2 plus c, and we can cancel these two terms. Finally our answer is, first term is 2 by 7 x power 7 by 2 plus 2 x power 3 by 2 plus 8 x power half plus c. Next problem, we have integration of cosecant x into cosecant x plus cot x. Let's multiply this inside. So cosecant x into cosecant x will give cosecant square x plus cosecant x into cot x. We have to write it as a second term. Now applying formula for each, integration of cosecant square is minus cot x, and integration of cosecant x cot x is minus cosecant x plus c. The same way, next problem, we have integration of secant x into secant x plus tan x. This, when I multiply inside, first term will be secant square x and second term is secant x tan x, then finally into dx. Then formula for integration of secant square x is tan x, and integration of secant x tan x is secant x, and plus c. Next problem, we have integration of 2 minus 3 sin x by cos square x. Let's divide this individually. So 2 by cos square x, the first term, minus 3 sin x by cos square x, is the second term into dx. Now when I carry this up, we get 2 secant square x, because 1 by cos x is secant x. So 1 by cos square x is secant square x, minus 3. This sin by cos square can be written as sin x by cos x into cos x. So this part will become tan x and the remaining is secant x. So I can write this as 3 tan x and 1 by cos x is secant x and dx. Now formula for integration of secant square x is tan x, the constant will be written as it is, minus 3. Integration of secant x tan x is secant x. So secant x plus c. Now next problem, we have integration of secant square x by cosecant square x. This can be written as integration of 1 by cos square x whole divided by 1 by sin square x dx. Now the denominator, we have fraction 1 by sin square x, that will be multiplied by its reciprocal, which is sin square x by 1. Totally this is sin square x by cos square x, which is tan square x, but we don't have integration formula for tan square x. Using the identity, that is secant square x minus tan square x equal to 1, this tan square x can be written as secant square x minus 1. If I take this to the other side, I get tan square x, and 1 will come to this side. So secant square x minus 1 is tan square x. So now this tan square x is replaced with secant square x minus 1. Now the integration of secant square x is tan x, then minus 1 integration is minus x plus c. Next problem, integral root x minus 1 by root x whole square. This is of the form a minus b whole square. Its expansion is a square minus 2ab plus b square. So when we expand this, it will become a square, which is root x square, which is x, minus 2ab, then plus b square, which is 1 by x. We can cancel this root x and root x. Then we left with integral x minus 2 plus 1 by x dx. X integration is x square by 2 minus 2 integration is 2x. 1 by x integration is log x plus c. Next problem, we have integration of 2 power x plus 3 power x by 5 power x dx. Let's divide this individually. So this is 2 power x by 5 power x plus 3 power x by 5 power x dx, and this will become 2 by 5 whole power x. In the same way, the second term is 3 by 5 whole power x dx, and we are going to apply the formula. Integration of a power x dx is a power x by log a plus c. So here this 2 by 5 itself a constant like a, so its integration is 2 by 5 whole power x divided by log a, so log 2 by 5 plus 3 by 5 whole power x whole divided by log 3 by 5 plus c. The same problem can also be given in terms of a, b and c. That is integral a power x plus b power x by c power x dx. So we can divide individually a by c and make it as whole power x plus b by c whole power x dx. Applying the same formula, this whole power x divided by log a by c plus b by c whole power x divided by log b by c and some constant. Already there is c, so I put another constant k. Now let's see the next problem. The question is integral e power 5 log x minus e power 4 log x by e power 3 log x minus e power 2 log x. We have the basic rules of exponential. Whenever we have e power a log b, we can use the power rule and carry this a to this power of b. So this will become e power log b power a, and once again this will get removed, so it will become only b power a. So we are going to apply this here. So first term will be e power log x power 5 minus e power log x power 4 whole divided by e power log x power 3 minus e power log x power 2. Now after removing e and log, we have first term as x power 5, second term x power 4, third term in the denominator, that is the first term in the denominator, x cube minus x square dx. Now from the numerator we can take x power 4 common, so we have x minus 1. From the denominator we can take x square common, so we have x minus 1. We can cancel both x minus 1, and after cancelling x power 4 by x square, we are left with only x square dx, and its integration is x cube by 3 plus c.